What's up, everybody? We're back with another one, and it's Dr. J once again, and we're just in this series talking about chemistry. That's all we're doing. Okay, let's get started. Gases. Okay, so we talked about gases, solids, and liquids. Okay, we kind of brushed over them, but let's just take a little bit deeper look into gases. So gases are basically you got these small particles, okay, and we have to think of them as moving around just on their own. Okay, so they're different from the liquids, right? Which there's a connection there, and definitely different from solids as they're very compact. So gases are free. They're the freest molecule of them all. You know what I'm saying? They could do whatever they want to do. Okay, because they're just going around, constantly going around, right? Even right now, as I'm breathing, I'm surrounded by air, gas. Okay, so this is a free particle we have here. Now, like I mentioned before, gases are constantly flying around, and as they are flying around, these gases are actually colliding with each other. Okay, so there's some collisions taking place, depending. All right, but they're bumping into each other. Okay, so gases, even though they're so small and we can't necessarily see them, they are colliding. Okay, now great example of this is, let's just look at this container here, right? Okay, what we're going to see here is we got some gas molecules, right? They're going around, bumping into each other, and what happens when you bump into something? It's going to create a force, and if you increase your force, right, you're going to have a higher pressure. That whole thing. If you guys want to learn more about KMT, just let me know in the comments. That's actually a theory describing the behavior of gases, kinetic molecular theory. If you guys didn't learn that in Chem 1, please let me know. We could definitely cover that. You just got to let me know. But anywho, we got gases going on here. You see this? Moving around, bumping around. And one thing that is a trait that gases have, unlike other say some matter, is that gases are highly compressible. Highly compressible. Okay. So because they're highly compressible, right, that basically means they're able to be squeezed together. Okay. And this is one example here. We have this volume here, and as we squeeze it down, right, they're being compressed together. Now, what we also see about gases is there's a large amount of space between the particles compared to the size of particles. So like how I mentioned before, okay? So because of this huge difference between the two, right, we're going to see a lot more area for our gas particles to move around in. And then let's just focus on this point. Therefore, the molar volume of the gas state of material is much larger than the molar volume of the solid or liquid state. If you don't remember molar volume, that's the unit conversion where it's 1 mole equals 22.4 liters. So right there, that's going to tell you that gases have a huge volume, right? When you're comparing it to like a solid or liquid. Key thing about gases is that they're compressible. Okay, I can't say that much. I can't say that as much as I can. They're compressible. That's the key thing you want to know, a key trait from gases. All right, they're highly compressible. And that's just because, as I mentioned before, these small particles are in this huge area. No matter if it's a 5-liter tank or a 25-liter tank. Okay, it doesn't matter. These particles are so small compared to these containers. Okay, so because of this area that they have, they're able to be squeezed together. Unlike solids, unlike solids, right? It's not easy for solids. Even liquids. If we look at this picture here, liquids are compressible. Okay, they're slightly compressible. We see at the left side here, this liquid, just put it in the container, you squeeze down, and it's going to be compressed a little bit. Not as much as our gas molecules, right? Look at all this space it has. And look what happens when you compress it, right? It's able to be fully compressed. We see all this space? All right, that's the key thing about gases. It has a lot of space compared to other things. And if we look at liquids, not that much space. Even when it's not being compressed at all, we can see that this liquid is really, really close together, unlike our gases over here. Okay, so no close contact, and that's the key thing about gases. No close contact. Because of that, they're able to move around very, very free. Okay, and this is one of the things about gases, because they're able to move around free, right? They can expand to any type of shape and fill that container that they're in. And that's only gases can do that. Only gases can do that, okay, when we're talking about the different states of matter. Okay, and when I say states of matter, we're just talking about the basic ones. All right, we're not talking about that extra stuff, plasma and all that stuff, okay? We're not going into space here. We're just talking about what we see on Earth: gases, liquids, and solids. Okay, that's all we're going to be covering here, guys. I just had to put that out there. There is another state of matter, but we're only going to be covering gases, liquids, and solids. Just three. If you guys are interested in that, let me know in the comments. Just let me know.